The concept is Buckingham's pi method or theorem. Write down the Buckingham pi theorem. Buckingham pi theorem. Write down. It is used to solve. It is used to solve. It is used to solve engineering problems. Buckingham pi theorem or method. It is used to solve engineering problems of dimensionless analysis. To solve engineering problems of dimensionless analysis. Okay. Now see, what is this method? So what we have seen various forms, MLT forms. These forms are all variables, and already we studied that there are two mainly categories: fundamental means independent, and derived quantity means which are dependent. Okay, so here any problem, that problem will have n number of variables. So in that problem, n number of variables, in that we are going to select 3 repeated variables. Repeated variable means fundamental variables. Okay, so n minus m, these will be what? Dimensionless forms. And that how to form? For that, here some mathematical technique. So that we will write. So write down here. If n number of independent variables, if problem contains n number of independent variables, okay, in a dimensional homogeneous equation, then it will contain m number of fundamental variables. Fundamental means independent or basic independent variables. Mostly these are 3. Which 3? One will be dimensional property, one will be geometric property, and one will be flow property. So these 3 fundamental variables we will take n. So here n minus m, these will be what? Dimensionless terms or forms. These are dimensionless terms, or these are called as pi terms. These are indicated by pi, letters pi terms. Mathematically, how it is written? So mathematically, write down. Mathematically, for example, if n means all the variable is a function of, okay, some quantity, say x1, x2, x3, x4, like this, x5, dash up to n number, x raised to xn. So in this, what we do, we select 3 fundamental variables. These are what? Fundamental means n numbers, fundamental variables out of these. Okay. Then here n minus m will be what? Pi terms. Okay, n minus pi terms. N minus m terms, how are written? So first pi terms, whatever terms are, first term pi 1. How to write? Pi 1 will be what? write the first fundamental variables that we have selected. Fundamental three variables we have selected: x2, x3, x4. Okay. Write these three variables in this form. Exponent of these we will write in this fashion: a1, b1, c1. These are exponent of fundamental variables. Okay. Now in this way, here next term pi2 also will be written in the form x2, x3, x4. In all terms, what I am saying, all terms, these fundamental terms will be coming. But here exponent we will write in this fashion. For second term we will write a2, b2, c2. For first term we have written a1, b1, c1. For second pi term exponent we have written a2, b2, c2. Likewise, you can have pi 3 terms. Suppose then we will use a3, b3, c3. Okay. In this way we can write. Okay. Now here x2, x3, x4. That is here. Now remaining terms are here. One term will be here. That we will multiply to this. Remaining term we will multiply to this. That is x5. So if there are 5 terms, then 3 terms will be fundamental, and remaining terms that we will take one term here, one term. So in this way, here we can write the equation. Then we have to solve. We have to solve. Solving these or simplifying these, we have to find value of a1, b1, c1, a2, b2, c2. We have to find value of a1, b1, c1, a2, b2, c2. Okay. Then we put these values over here. So putting these values again, we get pi1 is equal to one equation or formula. Pi2 is equal to one equation or formula. Okay, so these are what pi terms. These are pi terms. Now here we have to write relation among these terms. How one pi term will be function of another pi term. One term will be function of another pi term. Pi2 term will be function of pi1 to pi n minus 1 in this way. In this way we have to write find. Okay. Now there are some rules. We can take product of two pi terms. We can take division of two pi terms. You will see that in the numerator. Okay. This is called as Bukingham pi theorem. That is used to find the dimensionless numbers. Okay. Now we have to see how to select variables, fundamental variables. In the numerical, set of variables is given. So out of these variables, how to select fundamental variables. So here we will have first of all three categories. So there are three categories of fundamental variables. Three categories. Okay. First set is of geometric property. Geometric property. Variables which is used to indicate, to give information about the size of the object. Okay, that is called a geometric property. Here what will come? Length may come, height, breadth, width, diameter. Okay, like this. So here, this is all terms or all variables come under this category. First category, geometric properties. Second, flow property. Flow properties means all the properties which will give information about the flow, speed, its speed, its velocity, like that. Okay. So these are set of these property: velocity means speed and acceleration due to gravity. That is. Third category is fluid properties. Fluid. Set of the variables which give information about nature. So these properties are rho density, mu means viscosity, nu means kinematic viscosity, okay. Sigma means surface tension, okay. Power, torque, pressure difference. These all the properties are fluid properties. Here you can add specific weight, because specific weight is again like density. This is mass density, this is weight density. Mass density, weight density, dynamic viscosity, kinematic viscosity, surface tension. Power, this is the word power. Torque and pressure torque. So what numerical we will have, okay, problem. That numerical suppose contain set of all these properties, contain all properties, n is equal to, we will write here all the properties. See, all the properties is what? Length, okay, diameter, height, weight, okay. Then that v, velocity, speed, acceleration due to gravity. Then this third set, rho, specific weight, mu, sigma, power, torque, pressure drop, etc. So these are what? N variables. Out of these n variables, we have to select what? 3 fundamental variables. Okay. So fundamental variables means n variables. Fundamental. Or that depends on the numerical. In the numerical will have set of subnumericals. This I have taken all the variables. Whatever all the properties I have taken together. In actual numerical, there will be some of this. Out of that n, we have to take 3 variables, m variables. That is repeated variable or fundamental variable. How we can do that? Set of 3. So you can different way you can write. Different way means you can take together L, B, rho. One geometric property, one flow property, one fluid property, L, B, rho. You can take D, N, rho, D, N, rho. Okay. You can write it H, okay, this G, mu, H, G. One geometric property, one flow property, one fluid property. Depends, whatever is given to you. From that you have to select. So three fundamental variables. H, V, mu. H, V, mu. Next you can take H, V, mu in this way. Or you can take B, V, mu in this way. So, whatever are n number minus n we do, we will get some number that will be terms. Whatever terms, 3, 4, 5, that number, 5 terms, number of 5 terms you will get from the subtraction. And then you will have to write that all phi 1, phi 2, phi 3 equation form by the Bukingham pi theorem. So all these will have some, we will get ratio. Here we will get ratio. Here we will get ratio. Ratio of some terms. All these are what? Ratio of variables. So in this way, we have to use fundamental variables.